All right, welcome everyone. This is one of the first webinar series on kind of exploring retrieval augmented generation from the research side of things. And today I have the pleasure of being joined by Zhengbao, Frank, and Luyu, co-authors of the paper Active Retrieval Augmented Generation, otherwise known as FLAIR. And we're super excited to host them. And I'm super excited to talk about, both how kind of FLAIR helps advance this world of long-form retrieval augmented generation, as well as talk about some of the current limitations and future forward-looking directions of RAG and LLM-based retrieval in general. So, pleasure to meet you guys.
Yeah,
nice to meet you.
Awesome. Cool. So maybe let's to kick it off. Maybe you guys could just give a quick overview of kind of like the context as well as like the overview of the paper itself around active retrieval augmented generation. And I'm not sure if you guys have slides. If not, that's totally fine. But if you guys do, maybe that could help. You guys could help share the presentation as well.
Yeah, I do have a slides, so maybe I can share my screen.
Sweet. Well, I will let you guys take it away, and
Okay.
Feel free to give an introduction as well.
Yeah. So thank you for inviting us to join this online session, and I'm very happy to have the opportunity to talk about our recent work and also talk about retrieval augmented generation and also long form generation in general. And I do have a slide. So to give a brief intro of myself, I'm a PhD student from CMU working with RAM, and I'm currently mainly working on retrieval augmented language models and also knowledge-intensive tasks, something like question answering, and also long-form generation. And yeah, Luis is also working on similar topics. Maybe he can also give us a quick introduction.
Yeah, so hello, my name is Luyu Gao. I'm also from Carnegie Mellon, also doing my PhD. And I work on retrieval and also basically I work on the intersection between retrieval and language model generation and in general, so basically improve one with the other and things like that. Yeah.
Sweet.
Yeah, so I'm Frank. I'm also a PhD student in CMU. And my research interest is basically on like machine learning language models for software for code, like code generation and kind of stuff. And I want to use retrieval augmented methods to improve current ML for code models.
Yeah, cool. So yeah, so I think maybe I can take a few minutes to briefly go through our recent paper. And
yeah, that sounds great.
Yeah, let me share my screen.
And then for those of you in the audience, just a quick note, we'll leave some time at the end for questions if there are any. Otherwise, I'm also happy to ask a bunch of follow-up questions. And so just feel free to leave it in the chat. And then if we don't get to all the questions, happy to kind of like forward some of these offline as well.
Yeah, can you see my slides?
Yeah. Did you say, by the way, did you say you whipped this up in the past few hours? That's pretty impressive.
Sorry?
Did you say you put these together in the past few hours? Because that's,
yeah.
that's pretty impressive. Wow,
yeah. The slides.
Nice, yeah. Sorry for the short notice, but great. Feel free to take it away.
Yeah. So it's okay. It's just like a few slides. It's relatively easy to put them together.
Sweet.
Yeah, so this is our recent work. So it's a collaboration between CMU, Meta AI, and also CAI Lab. So the title of the paper of our work is Active Retrieval Augmented Generation. And before diving into our method, I would like to first briefly go through retrieval augmented generation, the standard way of doing this type of retrieval augmented generation for like large language model. So here is a figure I took from a blog post. So given the initial input question, which is who is the president of the US, usually the pipeline is that you will send the query to a retriever, and the retriever will return a bunch of documents. And based on both the question and the return documents, the large language model will generate the final answer. So you perform retrieval at the very beginning, retrieving all of the information you need, and then by conditioning on both the question and the retrieve documents, you generate the answer in a single forward run. So this is the standard way of doing retrieval augmented generation, and this is pretty much I would say it is both standard in academia and also standard, I guess, in industry. So those type of retrieval augmented generation has been demonstrated to be super effective for question answering, but most of the methods are evaluated on short form question answering. For example, in this case, the final answer is just a single entity, and which is Joe Biden. So it's relatively easy for the model to retrieve relevant information and generate the final entity. However, when it comes to long form generation, things are quite different. For example, if we want the language model to answer complex information seeking questions, for example, summarize the latest research work from CMU or Meta AI research, or if you want to push it further to ask the language model to generate an essay or a paper or even a book, for example, write an essay about global warming, things are really complicated because for those questions, the information needs are really complex. It usually requires gathering information from multiple sources and reasoning through those documents and generate a coherent long story using the language model. So it's pretty hard to gather all of the relevant or necessary information at the beginning of the generation. So this is our major motivation to propose active retrieval augmented generation. So the core idea is very simple. We just want to perform retrieval during generation whenever necessary. So imagine, for example, generating an essay about global warming, maybe by first retrieving a bunch of documents using the input question as the query, write an essay about global warming. You might end up with several documents, talking about global warming, and you might be able to generate the first section of the essay, which is the introduction section of the essay, based on those documents. However, when you want to generate details about this topic, for example, the cause of global warming or the consequences of global warming, you might want to refer to other documents that are not other information that are not included in the initial retrieval results. So this is our motivation to do this, to perform retrieval augmented generation actively. So this is essentially basically creating this for loop between retriever and language model. The language model will generate the output, and when the language model lacks certain knowledge about the upcoming generation, the language model can issue some queries to the retriever, and the retriever can return with a bunch of documents, which hopefully will help the language model to generate future content. So this is essentially creating this loop between retriever and language models so that the retrieval and the generation can interleave with each other to help generating long form content. To make this possible, we have several challenges, and I summarize them in this slide. So the first challenge is when to retrieve during generation. This is actually another trivial problem because imagine generating an essay, containing many paragraphs or sections. We need a method to tell us when to trigger retrieval. And when we want to perform retrieval, what to retrieve is another thing we need to figure out. What information is really needed given the current generation context, what is missing from the current generation. So this is another question we need to figure out before generating the next sentence, next text. And the last question is, given the retrieved documents, how to integrate those retrieved documents to help further generation. So those are the three major challenges we want to focus on in this paper. So given those challenges, we propose our method, which is called FLIRE, forward-looking active retrieval augmented generation. So based on this GIF, you can get pretty much a good sense of what we are doing in this method. So given the initial question, which is generate a summary about Joe Biden, the model will generate the output sentence by sentence. So in our method, we use sentence as the basic unit, to determine when to determine the generation procedure. So if the next sentence generated by the language model doesn't contain any low probability tokens, it basically means that the language model is pretty confident about the generation. So we can basically move forward. if the next sentence contains low probability tokens, it's basically indicative that the language model is lacking knowledge. So we probably should trigger retrieval to retrieve something to help the language model to get a better generation. So this is how we decide when to retrieve. We basically decide this based on the probability of the generated tokens. In this example, in this GIF, for the second sentence, it's talking about the education history of Joe Biden, and the model is uncertain about the university of the Joe Biden. So we stop here. We use this sentence as query to send it to a retriever, which returns a bunch of documents, and then we regenerate the sentence by conditioning on those documents. And then we move forward to the next sentence. And we do this iteratively until reaching the end of the generation. So it's essentially an iterative generation and retrieval pipeline where we use the language model probability to determine where to perform retrieval, and use the upcoming sentence as the query to generate to perform retrieval. So more specifically, regarding the three challenges I mentioned previously, when to retrieve, we use the upcoming sentence, whether the upcoming sentence contains low probability tokens to decide when to perform retrieval. And in terms of what to retrieve, we have two methods. The simplest one is directly use the upcoming sentence to perform retrieval. And before doing this, we mask out low probability tokens from the upcoming sentence and send it to the retriever to retrieve something. Another method is explicitly call a large language model to generate a query that could potentially lead to the upcoming sentence. For example, because in the second sentence, the language model is uncertain about the education history of Joe Biden. So we can prompt the language model to generate a question, which could be something like, what is the education, which college did Joe Biden go to, something like that, to generate a question like that, and then send it to the retriever to return some relevant documents. And given those return documents, we simply we always prepend those documents at the beginning to give the language model a better context to generate future content. So the whole pipeline is relatively easy to implement. It's relatively intuitive. We do this, iterative generation and retrieval to make it better at long form generation. So we tested this model on multiple benchmarks, including multi-hop QA, common sense reasoning, long form QA, and also open domain summarization. And we compare our methods with several baselines, including single time retrieval, which only triggers retrieval at the beginning of the generation, and also another baseline model called previous window retrieval, which is essentially retrieving.
सुनने के लिए थोड़ा सा ये टेक्निकल है. तुम लोगों को भी अंदर आना है तो अंदर आ जाना.
Sorry, I think I'm going to mute you. Okay, sorry about that.
Yeah,
go for it.
Yes, so another baseline is previous window retrieval, which is essentially trigger retrieval for a fixed window, for a fixed interval. For example, every sentence or every, for example, 16 tokens, and use the previous context as query. So comparing to both baselines, single time retrieval and retrieving information using the previous window, our methods consistently outperform baselines across all of the benchmarks.
Could you maybe, sorry, I have a bunch more questions, but like for this, maybe could you describe a little bit about like what the nature of these benchmarks could be? Just like kind of what is the form of the kind of like context, the questions, and how long are like the expected answers?
Yeah, so basically for those, for all of the numbers I included in this figure, we use automatic metrics because automatic metrics are relatively easier to to use. So for multi-hop QA, we basically evaluate whether the generated answer, the final answer, is correct or not. We have the final answer, final code answer, and we also have a long output generated by the model, and we extract the final answer from the long output. So to give you an example of multi-hop QA, the question could be, who is the daughter of the president of the US? So in order to generate the final answer, you need to first, find out who is the president and then find out who is the daughter. So we generate the whole reasoning process, using something like chain of thought, and then we extract the final answer from the output and compare it with the gold answer. So this is what we did for multi-hop QA. For common sense reasoning, it is similar. So the data set we used here is called strategy QA, which is all of the questions included in this benchmark are actually yes or no questions. So the final answer is always yes or no. We generate for this data set, similar to the multi-hop QA data sets, we generate a chain of thought reasoning process, the internal thinking process of the language model, and we extract the final yes and no answer generated by the model and compare it with the gold reference. And
quick question about the multi-hop QA. When you say like evaluate the generated answer versus the actual answer, how do you do that?
So I basically compare it's stream-based matching.
Okay, so you don't because there's like a line of work that uses like a language model to compare the two, but you just do some sort of like string-based matching.
Yeah, I think for multi-hop QA, because the final answer is only a single entity, so stream-based matching is actually not that hard to do. However, for long-form generation, for example, for ASQA and wiki aspect, so those data sets are basically generating longer content. For SQA is a data set where the input question is ambiguous. So for example, who is the most popular, what is the most popular soccer player? So you might have multiple entities. You have the most popular, women soccer player or men soccer player. So you need to consider multiple interpretations of the ambiguous question and to generate a coherent, a long answer. And for wiki ASP, it is a summarization data set. All of the questions are similar to the questions I have in the previous figure. So generate a summary about a particular entity, including several aspects. So for both SQA and wiki ASP, the outputs are usually much longer. So for those data sets, we use several existing metrics to measure the performance, including root, which is a standard metric for for comparing long generated outputs with gold answer. And we also use other metrics like entity F1, which basically extract entity from the output and compare it with the gold answer. Yeah, and we plan to also evaluate our methods using human evaluation, or the method you just mentioned, evaluating using the most advanced language models like GPT-4. I think most of the recent papers to align language models, they use GPT-4 model to compare generations. So we are also planning to do that, but we didn't do this in this paper because those evaluations are relatively expensive. We need to hire human labelers, or we need to use GPT-4, which is quite expensive for us. So, but yeah, we do plan to do that in the future.
Makes sense.
Yeah, have the budget. Yeah, so this is a quick summary of our experimental results, and I have a few other directions in mind that could be done in the future. For example, how to develop advanced methods to control or trigger retrieval during generation, and how to make this whole pipeline efficient. Currently, the implementation is just a vanilla implementation, which is slower than only performing retrieval at the beginning. So how to make this whole pipeline, the interleading retrieval and generation, more efficient is another direction that is particularly important in industry. And the last one is align language models or fine-tune language models to better collaborate with retrievers or tools. This is definitely a very big challenge, and I would say still challenging for the most state-of-the-art language models. Yeah, this is a quick summary, and here's some resource. If you are interested in the details of the paper, feel free to read the paper and check out the code. If you have any questions, I'm happy to take any questions.
Great. This is an awesome presentation. I think, honestly, the diagrams are super clear. The examples, I like the kind of like animations and the visuals too. So thanks for doing this. Maybe a very first question is, So you have FLAIR, which is like active retrieval augmented generation for a long form generation. What were kind of like the baselines before this? Like, so you have like single shot retrieval and then generation. And then if I remember correctly, was there also just like a version where you just operate at like a fixed cadence? Like, you know, instead of like looking at low probability tokens, you always just do retrieval for every sentence or something?
Yeah, exactly. So before this, there are two baselines. The first one is single retrieval, only retrieving at the beginning. And the second type of baseline is what you just mentioned, retrieving for every sentence or for every 16 tokens or every 32 tokens. I think a notable paper is actually from DeepMind. The name of the model is called Retrieval. What they did is that they will trigger retrieval for every 32 tokens, if I remember correctly. So they will do this retrieval, at a fixed interval and trigger retrieval for, at a fixed pace. So those are the previous methods we compare with.
Got it. Makes sense. And then in terms of like the form or retrieval, like what is the input query? And then how do you do retrieval? Is it like through some sort of like embedding based lookup? What's like the actual formulation of this?
Yeah, so most approach, they use either the previous sentence to do as a query, or they use the previous window, let's say 16 tokens or 32 tokens as the query. And I think there are two types of retrievers, either using those, lexical tokens and rely on sparse retrieval like BM25, or they use the embedding of those tokens. So I think in the case of Retrieval, what they did is that they have another retriever, which is actually based on BERT. They use the BERT model to encode the previous window or the previous sentence to generate embedding, and use that embedding to look up relevant information from the data store, which is also built based on vectors of documents. So yeah, I think in our paper, we only use BM25, but I think
I see.
Potentially our method could be, it also depends on the quality of the dense retriever. If the dense retriever is well trained on a large data set, if the dense retriever is robust, our methods could also potentially benefit from using dense retrievers to retrieve relevant information.
Makes a lot of sense. I mean, I guess the retrieval part is just like some abstraction that you call, right? Throughout this like iterative process.
Yeah, exactly.
Makes sense. Moving along to, you mentioned like there's two modes for FLAIR, and I just want to kind of like dig into that a little bit more. There's both like the low probability tokens, as well as like having the language model generate like an explicit query, like basically in the output say like, hey, please search for something, if I'm understanding that correctly. What are some of the trade-offs between both, and what's kind of like the performance differences that you can observe?
Yeah, this is a really good question. So I think that this is basically which one you prefer to use mainly depends on the trade-off between large language model and retriever. So if the large language model is super strong and the retriever is relatively weak, I would suggest using the explicit query one, where you generate a query containing several keywords, or a single keyword or several keywords using the language model, and issue those keywords to the retriever. Because the retriever is relatively weak, it might only take, it might only be able to understand keyword-based queries. However, if the retriever is strong, for example, if you use dense retriever, which is trained on large collection of sentences, maybe you can get rid of this intermediate step of generating queries. You can directly use the next sentence and encode the sentence using a dense retriever to get embedding. Hopefully the embedding could cover potential information needs that are required to generate the next sentence. So you can just rely on the embedding to retrieve relevant information. So I think there's a trade-off between, which one you trust more. If you trust language model more, you should generate queries and, just use a relatively weak or, relatively off-the-shelf retriever to do the retrieval. However, if you can fine-tune the retriever to make it stronger at encoding sentences, with potentially misleading information, then you can get rid of this step and just let the retriever do the job.
That's a good point. I like the I like the whole kind of distinction between having like a strong language model and a weak retriever versus like, kind of assuming the retrieval is good enough to kind of like insert a more complex query into it as well. This also might be a bit of a detail, but did you notice a difference with, like, for instance, the implicit query? It seems like you're kind of hallucinating a new sentence versus like when you generate a new query, it seems like that's more of a question format. So did you notice a difference when you like try to enter something that's like more of a question versus like hallucinating like an answer, if that makes sense? And did that impact retrieval performance at all?
Yeah, so I was expecting the two methods to have different performance. And me as a human, when I look at those, generated queries from language model and also the original upcoming sentence, with potentially misleading information, I prefer the second one, which is, generating the queries using language model, because it seems to be more clear to me, what the language model is looking for, and we can just use those queries to retrieve relevant information. However, in my experiments, both methods perform equally good. So
Gotcha.
I think it really depends on the data set. If the data set is relatively simple, maybe advanced, generating more queries using the language model might not be necessary. But I guess because all of the benchmarks we use in the paper, the longest benchmark usually contains, I would say, 5 to 10 sentences in total for the generated output, which is definitely longer than short form QA, which usually generate a single entity or a few entity names, but it's not that long compared to, for example, generating essays or generating a whole paragraph, summarizing relatively complex information. So I guess my assumption is that if we move further to data sets where the output is even longer and the information need is more complex, using this query generation approach might give us better performance. But currently, I think this is also something that I want to mention. In academia, long-form generation data set is really lacking, so lagging behind. So we currently don't have really good long-form generation benchmarks or evaluation metrics to help us push the limit even further.
Gotcha. And that actually is a perfect segue into my next question. And I'm curious to get your guys' thoughts on this. Is what are some of the limitations of FLAIR? Like it seems like it's tackling a pretty like underexplored problem of like long-form generation. What are some of like the limitations that you're excited about like potentially exploring and solving as future work?
Yeah, so I would say the biggest limitation would be efficiency, because this is basically, in order to implement this, you need to stop the generation whenever you need to retrieve something. So this is, I would say, for if you want to treat, for example, in the worst case for our method, we need to trigger retrieval for every sentence. If the output contains 10 sentences, you need to retrieve information 10 times, which is quite a computation overhead. So that is something I think is really important. If we want to make it into production, we really need to make this model efficient. I think there are potentially two ways to make it more efficient. The first one is reduce the frequency of the retrieval. So there's actually also a trade-off between the frequency of the retrieval and the number of documents you want to retrieve. If you retrieve information with a lower frequency, you probably need to retrieve more documents for each time you call the retriever, because you need more information to generate a relatively long output, long paragraph. However, if you trigger the retrieval relatively frequently, probably you don't need to return that many documents. So there's a trade-off between.
Oh, I see.
It's something like a breadth and depth search. So you have to call the retriever how many documents you want the model to return, you want the retriever to return, and how many the frequency of the retriever. So yeah, I think this is there's a trade-off. Potentially, we can improve the efficiency of our method, FLAIR method, by reducing the frequency and also limiting the number of documents we retrieve for each call.
Yeah, that seems very practical. Like for instance, like if you retrieve a lot of documents, and you might be able to generate like a lot more stuff at once, and then it might be a little faster, but you might lose out on some like more granular information. Versus if you retrieve just like every half sentence or every sentence, then you might be able to limit retrieval a little bit. Makes sense. That's super cool. Moving kind of like a little bit more broadly, and this might like talk a little bit about like general kind of retrieval augmented generation and also agent related stuff. And this is something that I'm very interested in understanding is, yeah, so like you talked a little bit about chain of thought, what is the relationship between your paper and this whole like line of work around like agents, like React, chain of thought, all these things?
Yeah, I think they're definitely highly related in terms of we want to augment language model in terms of the ability they are lacking. So retrieval is mainly helping the language model in terms of knowledge, because language model do not have up-to-date information about the world. And other tools, for example, calculator or Python code interpreters, those are helping language model with other abilities, something like math abilities and reasoning abilities. So I think they are basically in the same line of helping augmenting language models with respect to all kinds of abilities. And I think that they are also similar in terms of the way the tool interact with the language model. So for example, in chain of thought or in React, they also do this iterative iterative generation and tool usage. So the language model usually take the input question and generate some reasoning process, and based on the reasoning process, the model will also trigger certain actions from the tool library to help the language model to determine, for example, what is the next object that the language model needs to generate. So from this perspective, our method is also relevant to previous approach. I would say potentially, I think in the future, I think there are basically two types of opinions regarding this. One is that just consider retrieval as a specific tool, similar to other tools, and we can call whatever tools whenever needed. And another opinion is that retrieval is different from the other tools. For example, if you check GPT-4, if you have access to GPT-4 and ChatGPT plugin, you can see that they have two interfaces. One for retrieval augmented GPT-4, which is called something like GPT-4 with browser, something like that. And they have another interface for the other tools. So I think the reason why OpenAI did this is because retrieval can definitely be regarded as a tool, but it's quite different from the other tools. For example, calendar or something like Google Flight or Google Place. Those tools can be, I would say, integrated into language models in a relatively simple using a relatively simple method. However, if we want to combine retrieval with language models, it's usually like more complicated. And also the frequency of using retrieval is definitely higher than the other tools, I would say. So I think there's also a paper called Toolformer, and they generate data where they use additional tools to help language model improving the generation quality. And if I remember correctly, in their data set, more than 80% of the calls tool usage are actually using retrievers. So the remaining 20% are using other tools like calendar or code interpreter. So
got it. I think you kind of you touched upon this point, but I think it's a very interesting broad point that we're also thinking about a lot. It's this idea of so you said there's two types of opinions, and the first opinion is retrieval is this a tool similar to other tools in I assume some sort of agent loop, right? And this agent loop can be relatively general. So a React agent, AutoGPT, any sort of general agent loop out there. And this is almost like a kind of general AGI type interface that can take in any task and supposedly fulfill any goal. And one of them could include long form generation. Hypothetically, this thing should be able to do that. But then the other approach, which is kind of I guess more in the spirit of this paper, is yeah, you maybe want some sort of specific, more constrained flow for some sort of long-term generation that allows you to generate long pieces of content very well, because that's the main focus of this type of technique. Would you say that's kind of a rough categorization of this, or are there kind of other relationships between the two?
Yeah, I think just exactly like what you said, I think there are basically two types of opinions on this. And honest with you, I'm not sure which one is better. So I'm currently on the fence. Which one is the future, or which one is more practical or more efficient or more effective. So I think that the first opinion, treating Retriever as a tool, just like other tools, is better in terms of the generalization ability. You just develop this a general concept of collaboration between agents and between agents and tools. So and this one can be generalized to potentially any tool. So when you have potentially have a new retriever, or a new data source, you can just plug them in. So this is definitely easier to use at a larger scale with more tools. However, you might lack quality with respect to some nuances. For example, if you want to generate if the language model is lacking certain knowledge, and that the model might benefit more from this finer control between retrieval and generation. So yeah, I think it's also a trade-off between how much generalization ability you want to get from the tool augmented language models versus how deeper you want the model to collaborate with the tool or the retriever.
Sweet. And then last question before I turn it over to answering some of the questions in the chat. How, like you mentioned, there's some challenges in getting like a data set for like long form generation. How would you think about getting that, and how would you potentially do evaluation on long form generation?
Yeah, this is a very good question and also challenging. So which is potentially out of my expertise, but I think collecting data is one thing, and evaluating the output is another thing. So I think in terms of collecting data sets, there are tons of user interactions on the internet between users and ChatGPT. So we can take all of those and potentially filter those questions to develop a benchmark that is both realistic and challenging. But I would say the harder thing could be evaluation. So how to evaluate the generation, because all of the automatic metrics are currently failing. So I think how to develop metrics is definitely a super important direction for the future.
Also, if you generate like a book, right? Like, how do you evaluate how good that book is? I don't know. Just like I'm just thinking about like hypotheticals. Like at a certain point, it might not be about like content matching, but also about the quality of the writing, like the creativity, like all these different things too.
Yeah.
Cool. I think it's obviously it seems like there's a lot of problems in the space, and this is great work and great step towards kind of like solving that. And I'm just very interested to see how this evolves. Turning it over to some questions in the chat. I think Kevin asked, so is the token probability of the generated token the only metric for kind of determining if it's reliable or not?
Yeah, so that's a good question. So currently, that's the only metric we use to determine, whether to trigger retrieval or not. And we made this decision mainly because there have been several papers showing that language models are relatively well calibrated, so that the probability of the language model can basically is basically a reliable indicator of the confidence of the language model. So we basically use this metric as a single metric to determine when to perform retrieval. However, I think in the future there could be other methods to do this, more advanced methods to do this. And I think one potential way to do this is basically if the language model can generate search queries proactively, then whenever the model generates a query, we can stop the generation and use the query to perform retrieval. So that is.
Isn't that kind of like your explicit query, but you're just saying kind of more on a token level?
Yeah, it's similar to that, but in our approach, what we did is that we first generate the next sentence, and we take the sentence and ask the language model, it could be another language model, to generate several queries. That could be potentially helpful to refine the sentence.
I see.
I think because we use a text affinity model, the model from OpenAI in our paper, which we do not have access to their weights. We cannot modify the model, so we cannot fine-tune the model to make it stronger at generation queries. However, if you have access, for example, if you use open source models like Llama or whatever models you have, you can potentially fine-tune the model to generate queries proactively, and use those queries to determine whenever the model generates a query, you stop the generation and trigger retrieval. So that could be another alternative to do this.
Makes sense. Next question is, I guess to reword it a bit, what are some kind of like industry use cases of a type of work like this?
I think this is potentially useful in all sorts of long form generation tasks. I think, as far as I know, both Bing Chat and Perplexity.ai, both of them are using retrieval to augment generation. And based on my observation, both of them only trigger retrieval at the beginning of the generation. So if you check their demo, usually they will perform, for example, they will trigger something like, they will generate something like 3 queries at the beginning and use those queries to retrieve a bunch of documents and then summarize those documents into, either a paragraph or, several sentences. I think if we want to even make this generation longer, our method could be helpful to, for example, for each section or for each paragraph, you can trigger the retrieval method, trigger the retrieval to generate to retrieve several documents and generate the next section or next paragraph.
Sweet. I think Ala asks, what's the LLM used for the generation step, or the last generation step?
So we use text Davinci 003, which is instruct GPT model from OpenAI that is aligned using human feedback. So that's the model we use. And potentially our methods can be also applied to ChatGPT, which is called GPT Turbo in the OpenAI model hub. So the reason why we didn't use ChatGPT is because, first of all, ChatGPT didn't return probabilities of tokens. So it only returns the generated text. It didn't return the associated token probabilities. However, our method relies on the token probability, so we were not able to experiment our method on ChatGPT. But if you have access to the token, but I guess in the future, ChatGPT, as long as ChatGPT can return the probability of the tokens, we can also test our methods on a ChatGPT model.
Makes sense. And then I think Andrew asks, what retrieval method did you use and any experiments? I think you guys mentioned it was like BM25, right?
Yeah. So like what you said, we mainly focus on this, iterative retrieval, interleaving between retrieval and generation. So we just treat retrieval as the off-the-shelf model. So in our paper, we just use BM25 over Wikipedia documents as the search engine. We actually have 2 corpus. One is Wikipedia corpus, and the other one is using Bing Search API, which will potentially retrieve documents from the open web. So, but for both of them, I didn't use retrievers. We use sparse retrievers.
Makes sense. Sunil asks, we probably have time to get through the last 3 questions. How can we integrate this with our own search results? That may include filtering or faceting.
You mean mainly something like if you have like personal data sets or personal retrieval corpus?
Yeah, I'm actually not sure. Maybe if you'd be able to, yeah, okay.
Yeah, I think if you have a personal data set that you want to augment like model, you can just take the methods and replace the index, the retrieval index, with your own index, and all the other things should remain the same. You potentially you don't need to modify the other components, and you should work out of the box. However, I'm not sure about the performance, but the whole pipeline can be run, by just replacing the index with your own index.
Sweet. Clint asks, how do you determine the threshold of low probability tokens? I think that's a good question.
Yeah, that's a good question. So this indeed requires some hyperparameter tuning. So my observation is that it really depends on the data set. For some data sets, retrieving with a lower threshold is better. So it depends on the retrieval frequency. For some data sets, retrieving more frequently is helpful. So for those data sets, you might want to set a relatively higher threshold to trigger retrieval more frequently. However, for the other cases where retrieval, you do not necessarily need to perform retrieval for every sentence. You can set a relatively low threshold to make the language model retrieve less frequently. So in our case, for most of the model, we either use 0.4 as the threshold or 0.8 as a threshold. So that's like two different settings, two different trade-offs.
Interesting. Yeah, I feel like once you have a top K, you might want to just like hyperparameter tuning on like a training set or something, just to see like what's optimal value.
Yeah, we can. Yeah, if you have data depth set in the parameter, you can definitely do that. But we didn't have that amount of because we use TextApty model, which is quite expensive. So exhaustively iterating over all of the hyperparameter settings might be too expensive for us. So we just ended up using a few settings that works good for us.
Sweet. And then last but not least, a question from Kevin. How does the retriever handle cases where there are multiple sources of truth? So does it pick a single source? Is there a mechanism for that?
Yeah, that's a good question. I didn't manually inspect those retrieval results. I think in most of the data sets we used, we mainly retrieve something like 3 to 5 documents for each query. So I guess for some cases, the document, the language model might take information mainly from a single document. For the other cases, the language model might combine information from multiple documents. So I think both are possible, but I to be honest, I didn't check those return documents. I think it also depends on the task. If the task requires combining information, summarizing information from multiple sources, the model might summarizing, information from all of the retrieved documents. However, for the other cases, the model might just take the answer or take the useful information from a single document.
Yeah, and the burden is probably partly on the retriever too, right? I mean, like if you have a bad retriever, it's just not going to give you the right results. But if you have something that can execute and retrieve like dynamic numbers of documents, then that's great for you.
Yeah.
Sweet. Okay. Well, I think that's it. And honestly, yeah, thanks so much for a great presentation. I personally learned a lot. I hope this was helpful to the audience as well. And I'm super excited to have this recording be shared. And yeah, thanks so much again for coming.
Yeah, thanks everyone. Thanks for having us.
Yeah, thanks for having us. See you.
Thanks everyone.
Bye.
Okay. Bye.